Bismillahirrahmanirrahim. I am Dr. Amir Badshah, lecturer in Department of Chemistry, Kohat University of Science and Technology. Today the topic of our lecture is silicones, their type and uses of silicones. This is lecture number 38 from the course Basic Inorganic Chemistry First, having code Chem 112. The table of outlines is introduction, nomenclature, preparations of silicones, types of silicones, and uses of silicones, and at the end we will mention some references for detailed study. First, we will come to the introduction. The word silicone was introduced in 1901 by a scientist. His name was Kipping for the first time. The general structure of silicone is shown here. Here it is a straight chain whose skeleton consists of silicon in oxygen, and the side chain is that of alkyl group. In this case, in many cases it may be aromatic rings too. These compounds are also called polyorganosiloxanes because it has organic part as with 8 siloxane. We will discuss in detail that what is siloxane. The general formula of this compound is R2SiO whole N. The R group may be alkyl group or phenyl group or any aromatic ring. Since if you look to the structure, it has mainly both organic as well as inorganic part. This part is organic part as well as this part too is an organic part, but the part which consists of the skeleton of the silicone is made of inorganic. So that's why such type of polymer are also called hybrid polymer. If you look to the backbone, it has the repeating bond of silicon and oxygen. You see that it has silicon and oxygen, then again silicon and oxygens. They are repeated, and this bond is called siloxane. So that's why these compounds are also called polysiloxane. So we can call this compound polysiloxane first. You can also say this polyorganosiloxane, or you can say only silicones. Various properties are developed in these silicones by changing the length of the polymer, or by changing the side group, or by the cross-linking group. With the help of these changes, we can develop different properties in the compound which is suitable for the specific uses. The change length, this is the change. We can make it short or we can make large. It is depend upon for the purpose that for which we want to use it, and its variation can be also occur by this change. This organic part can be changed. This may be small alkyl group or large alkyl group or phenyl group or other aromatic group too. Cross-linking are those which join the chain with each other. For example, this is a chain, this is a chain, in cross-linker are the group which join these changes. So the cross-linkers is another factor which change their structure and hence produce change in their properties too. In this slide we will discuss about the nomenclature of the silicone's polymers. But silicone is not only the one compound of silicon. Silicon maybe exists in alone form or in some other compounds. So what is the name of those compounds in which silicons are present? So if it is bonded, if it is alone, so such compounds, then it is in elemental state and it is called silicon. But if the silicon is bonded with 4 oxygen atom, as you see here, oxygen atom, 4 oxygen atom, then such compound are called silica. And if the silicon is bonded to 4 different atoms, maybe hydrogen or maybe chlorine, maybe halogens, then such type of compound are called silanes. And if it is bonded with 2 oxygen atom and into organic group, then such type of compound are called siloxanes. So we will discuss here only siloxanes. Preparations of silicones. Silicones are the preparation of silicone mainly take place in 3 steps. In the first step involve the preparations of chlorosilane, and in the second step involve the hydrolysis of chlorosilane, in a result of which we get silanol. In this we will discuss in the third step, and in the third step the condensation of silanol take place. So we will first prepare the chlorosilane, in the second step hydrolysis of the chlorosilane which forms silanol, and in the third step condensation of the silanol will take place to get we will get silicones. So first we will come to the synthesis of chlorosilanes. There are 2 methods for the preparation of chlorosilanes: direct method and indirect method. In the direct method, silicon is treated with alkyl halide as shown here, and we get chlorosilane. But how silicon is obtained? Silicon is not present in pre-state. It mostly exists in the form of silicates, where silica is the very famous and it is easily available. So silicon is obtained from silica by reaction with carbon, where silicon dioxide react with carbon in the form of coke, and the silicon dioxide is converted to silicon, and then oxygen is taken by carbon and converted into carbon monoxide. And then this silicon which is obtained from this is treated with alkyl halide to form dichlorodialkyl silanes. The amount of the different type of silane is possible. This is depend on the amount we use, the molar amount of the alkyl halide we use. You will get monoalkylated, dialkylated as well as trialkylated. This depends upon on the amount of the alkyl halide we use in this reaction. This reaction is a little economical. The reason is that because only one step is used in their preparations. There are no multiple steps, so only 2 chemicals are used, and it is one step too. So on one side it is economical and the yield is also good. But the problem in this reaction is that a very high temperature is needed for that reaction. So if we use alkyl group of higher change, then it is possible that these alkyl will be decomposed. So on one side it is good, but on the other side it has some problem too. In the indirect method, these silane can be obtained by the reaction of Grignard reagent in different moles with tetrachlorosilane. In the previous one, we used silicon only in the elemental state and alkyl halide in the alkyl halide in alkyl halide form. But here alkyl halides are used in the form of Grignard reagent, and silicon is used in the form of tetrachlorosilane. Now, first, how these alkyl magnesium halide or Grignard reagent is obtained. It is obtained by the treatment of alkyl halide with magnesium at very low temperature in the presence of ether, and we get Grignard reagent. Grignard reagent is a very famous reagent. It was introduced by Victor Grignard and it has many applications. So Victor and Grignard also got Nobel Prize over this reaction. When 1 mole of Grignard reagent react with 1 mole of tetrachlorosilane, we will get monoalkyl trichlorosilane, and along with that we will get 1 mole of magnesium chloride 2 is a byproduct. If it reacts with 2 mole of Grignard reagent with 1 mole of tetrachlorosilane, then we will get dialkyl dichlorosilane along with the 2 mole of magnesium chloride is a byproduct. And similarly, if we treated this with 3 mole, so we will get trialkyl chlorosilane along with 3 mole of magnesium chloride. This reactions, with the help of this reaction, it is possible to get various alkylated, maybe small chain, maybe large chains, maybe aromatic rings. But the other problem is that why it is so, because here the temperature is low. There is no possibility of breaking up the alkyl group at high temperature because the temperature is low. But it is a less economical one because there are multi steps involved. When the alkyl halide is used in the form of Grignard reagent, similarly silicon is used in the form of tetrachlorosilane, and then further it is treated. So there are many steps involved in their preparation, so that's why this is a little bit less economical. And the second step, hydrolysis of the chlorosilane takes place, and as a result of hydrolysis of chlorosilane we get silanol. How they get it? For example, the product obtained depend upon other reagent used. If you use trialkylated silane and treat it with water, you will get trihydroxy alkyl silane. If dialkyl silane is hydrolyzed, then you will get dihydroxy silane. And similarly, if trialkylated silane is hydrolyzed, then we will get monohydroxy silane. Third step is the condensation of silanols, as a result of which we will get silicones. Silicones, mainly on the base of their structure, is of 3 types. They may be linear, they may be cyclic, and they may be cross-linked. So linear silicones, these are the formation of the product. It is depend upon where the linear silicones will be obtained and how we will get the cyclic one and how we will get the cross-link one. This depend upon on the structure of the monomer in as well as on the conditions. It means there are 3 types: linear, cyclic, and cross-link or 3D structure. How we can get this one, how we can get this one, and how we can get this one, this depend upon on the structure of the monomer that we use in not only structure but also depend upon on the conditions too. For example, linear silicone is obtained by the dihydroxy alcohol, by the dihydroxy silane, and by condensation of that we get the linear silicone. The linear silicone is that one in which in which they are arranged in the form of chains. Similarly again silicon and then again oxygen and so on. So they are arranged in the form of change. So due to this arrangement in change, such structure are called linear silicons. Cyclic silicons is also obtained from the dihydroxysilane, but here is the difference. In the former case, there was no need of careful heating, but here we will need a careful heating, and as a result of careful heating, we will get the cyclic silicons as shown here. Here the silicon and oxygen are alternate with each other. Each silicon is connected with two oxygen. Silicon are connected, and each oxygen is connected with two silicons. And at the same time, silicon is also connected with two organic part. The cross-linked silicons, how these obtained? These can be obtained by the trihydroxysilanes. If we use trihydroxysilane as the starting unit, then we will get the cross-linked silane as shown here. Here the silicon is arranged on one side in the chain. Similarly, it also here in the chain, but these chains are connected with each other through cross-linker as shown here. So such type of structure which consists of chain as well as cross-links, then such structure are called cross-linked silicons. Further, these silicons can be also divided into different types, and this depends upon on the physical forms. Among them, the first one is the silicon fluids. The silicon fluids, mainly it consists of the linear silicons and cyclic silicons come under the silicon fluids. These are in the form of liquid state. The linear silicons having hydroxyl group at the ends, so first these are terminated with a monofunctional unit and then it is converted into silicon polymer as shown here. This is an example of linear silicons. It is treated with a monofunctional unit. This is a monofunctional unit having one OH. So when it is treated with this, so this water molecule is removed, and by the removal of this water molecule, it is connected as such. No, sorry, this oxygen is not here, and it is also bonded on the second side. So we will get such structure. In this structure, this is still a linear one, but here the hydroxyl group are not present at the end, and it is terminated by a monofunctional group, so it is come under the silicon fluids. Among the uses of these are used at very low temperature. Mainly they are used for lubrication purposes. In some countries the temperature get very low. So if a temperature is very low, so the liquid will change into solid state. But in that case, it has a characteristic of silicon fluids that at a very low temperature too, it cannot change into solid state. So we can easily use for lubrication purposes. Second is that at a very high temperature, it can work. Some other lubricating material also available, but at high temperature they can evaporate. But in this case, their boiling point is very high. They cannot evaporate easily, so they work at a very high temperature too. It is also used in the hydraulic fluids in the carriage in the cars. It is also used for insulations. For example, if we use some electric equipments, so these are covered over the silicone fluids and insulate them. and it also works. Some other material can be also used, but the problem in other material is that at high temperature they change into from the insulator into conductor, but such material cannot be changed into conductor at a very high temperature too. Second type of silicone resins. Silicone resins, they include cross-linked silicones as shown here, and they are used mostly for kitchen utensils and heat resistance equipments. They are also used for the electronic components due to high mechanical and electrical stability. It is also used as a sealant in the aircraft as well as in the automotive industries. The third one is the silicone rubber, which is also called elastomers. These include long chain silicones, but it should not they will be not in the pure form, but it will be mixed with pellets. The pellets may be pyrogenic silica. It is a type of silica. This is an example of silicone rubber elastomer, which is used which mixed with the pyrogenic silica and change into the elastomers. Mostly they are used for tubing in houses, the various type of flexible and soft tubes that we are used in our home for gardening, etc. They are made of such type of silicones. They may be also used as adhesives to combine two things together, and they may be also used for surgical aids. These are the references for further study. Thank you for watching this video.